Welcome to Mac 2311 for Engineers, exam number 4, free response number 3. In this question, they go ahead and they give you the acceleration function, and they ask you to find the velocity function and the position function. And they tell you, for both of them, the velocity and position is equal to 0 initially. So they give you that information to go ahead and find those integration constants that will pop up every time you take the antiderivative. And then at the very end, they ask you for what is the velocity and position after 1 second. So we'll get down to part C in a second. Just doing part A and B, finding the velocity and the position function. Well, if we take the antiderivative of this, it'll get us to the velocity function. But how do we take the antiderivative of this? Well, that's got to be a substitution. Because the inside, if you take the derivative, you'll get part of the outside, but it's going to differ by a constant. But that's all right if it differs by that, because you can just pull that constant out. So we can go ahead and say that u is equal to 1 plus t squared. So your du would be equal to just 2t dt. So then that means that we can go ahead and say the velocity is the integral of, and this is just going to be a u here, so it's going to be u squared on the bottom. You have a du here, and then because you can go ahead and divide this 2t over, and then that t will cancel out that t, and then this 2 will cancel out part of that 600, just giving you a 300. And that's what we just have this. And we know how to go ahead and take the integral of that, because this is actually just u to the negative 2. So you increase by 1 and divide. So increasing by 1 gives you u to the negative 1, divided by the negative, so that just gives you negative 300. And then you get a plus c term here. So that your velocity is equal to this, and then you want to go ahead and feed in that u. So you can say that you have negative 300 divided by 1 plus t squared, because you bring it back down, and then plus c. So now let's go ahead and solve for that c. Well, they said that the velocity was initially 0 at t equals 0. So we can just plug 0 in and set this equal to 0 to solve. If you plug 0 in here, you can see this just goes to negative 300, and that's 0 over on this side. So you can add the 300 over, and you get c equals 300. Right? You say that 0 is equal to negative 300 divided by 1 plus 0 plus c. Then you just add all this stuff over, and you get c equals 300. So that being said, your particular solution is actually going to be this minus 300. So now what's going to end up happening, rather plus, now what's going to end up happening is we need to take the antiderivative of this to go ahead and get our position function. So the position function, well, we know how to take the antiderivative of that, that's just tacking a t on. But we're going to have an integration constant on the end. So you know you'll have a 300t plus c, but this part here is a little bit trickier, just because we need to have this memorized. The negative 300 is just a constant, so that can be left alone. But 1 over 1 plus t squared, that's the antiderivative of that is actually going to be arctangent. You just have to have that memorized. So you can actually say this is negative 300 arctangent of t. And then now we can go ahead and solve out for that integration constant, because they said if we can plug in 0 for t, we can set this equal to 0. So if you plug in 0 here, this goes away. If you plug in 0 here, what's arctangent of 0? Well, saying arctangent of 0, that's just going to be some angle. So it's like saying tangent of what angle actually gives you 0. And the only angle that makes sense is going to be 0. Because remember, the range of arctangent is negative pi over 2 to pi over 2. So 0 is the only angle that actually falls in that range that would actually solve this equation. So this actually goes to 0. So this cancels out, that cancels out, so 0 equals c. So your c is actually 0, so it can go away. So this is going to be, we said that this right here was your velocity function, and this right here is going to be your position function. So that's parts A and B, and then part C says what is v of 1 and what is s of 1. So you just plug 1 into here, and you can see this is going to be negative 300 divided by 2, so that's negative 150 plus 300, which gives you a positive 150. So that's that guy. Then we can plug 1 into this. When you plug 1 into this, you get 300 minus, and then you're plugging 1 into this. So what's arctangent of 1? Well, arctangent of 1 is like saying tangent of what angle theta gives you 1. And the only angle inside the negative pi over 2 to pi over 2 range will be pi over 4. That's when sine and cosine equal each other. And tangent is just sine over cosine. So it's going to be pi over 4. So you're going to go ahead and actually say this is minus 300 times pi over 4. And you can simplify that down to just 300, because we can factor that 300 out and get 1 minus pi over 4. So then this would be the position, and this would be the velocity at t equals 1 second. So just a real quick recap, they gave you the acceleration. We took the antiderivative to get the velocity. We had to use a u substitution here to get the antiderivative, and you had an integration constant that we had to solve for to get our particular solution. What we did was it said that the initial velocity was 0, so we could plug in 0 and set equal to 0. And we solved for c and found out that was 300. Then we had to antiderive again to get the position function. We did that, and we got an integration constant. We just had to remember what the antiderivative of this was. And then we had to go ahead and find the integration constant by plugging in 0 and saying equal to 0. It ended up being that c was 0, so that went away. So this is our velocity, our position, and then you just want to know what the velocity and position were at t equals 1 second. So we just had to plug those in, and then you had to remember your arc trig functions and their values. And that's all there is to it.